Hi, Pen. Hi, everybody.
Hi, Suma.
You can hear me, right?
Yeah, I can hear you. I can hear you loud and clear.
Okay. Hi, Shailesh.
Yeah, hi. Good afternoon.
Hi. Yeah. Good afternoon. How are you?
Fine, fine.
Just give me some time. I'm trying to make some changes.
Okay.
Oh, data. I haven't seen you for a long, long time.
I'm going to start the broadcast now. You can see my screen.
No.
My screen is visible.
Yep, I can see your screen. It's not yet in full screen mode.
Now it's fine.
Yep, all good.
uh, we'll wait for 5 more minutes and then we can start.
Okay. Can you hear me, Suma?
Yes, I can hear you.
Okay. Thanks.
Dattadre, we cannot see you. Okay, I'll just start now. Welcome everyone. Welcome to today's webinar on optimizing ultra-pure water CAPEX and OPEX with Evoqua's Iron Pure CEDI, WAF screen filter and ATG UV technology. The speakers for today's webinar is Mr. Pan Jiashing, Technical Manager for Iron Pure Products Asia Pacific. He will be giving presentation on Iron Pure CEDI systems and technologies, and followed by ATG UV systems. Presentation would be handled by Samir Desane, Associate Technical Sales Engineer for South Asia region, and WAF automatic self-cleaning filters screen type presentation would be handled by Dattatreya Patil. He's a senior sales and service representative for South Asia region. We also have a guest speaker from Permionic Membranes Private Limited, Mr. Shailesh Patel. He's the head of projects at HPWD. The duration of this webinar would be covered in 1.5 hours, and in that 15 minutes will be for question and answers. The learning objectives for this webinar would be to gain practical knowledge about electrodeionization, that is CEDI technology, and how UV is important for TOC reduction, and how Evoqua's UV is third-party validated for disinfection performance, and how our WAF can reduce the maximum waste, WAF screen filters technology, and how Evoqua's combined iron pure CEDI, WAF, and ATG systems as one Evoqua solutions can help reduce footprint and meet the sustainability goals in most of the organizations. Before I start with the product presentation, I will take you to a brief overview about the brief corporate overview. Evoqua Water Technologies is a leader in water and wastewater treatment solutions provider. We have close to 4,500 team members spread across the globe. With 150, and our presence is there in 150 plus locations, and we have more than 38,000 customers worldwide with more than 200,000 installations. We have our offices in 10 countries, and as on September 2022, our revenue has been $1.74 billion. Moving on, this is a big news in water industry today. The two water leaders are one now. Evoqua has joined hands with Xylem, and as one water company, we want to solve the critical water challenges faced by our customers, communities, and planet. This is the evolution of Evoqua and our product portfolios, starting from 1913. In 1913, our first installation of our first chlorinator was installed across thousands, and by 1918, more than thousands plus cities had our sodium hypochlorite. Sorry. And by 1963, the aqualator surface aerator was introduced. And in 1980, our first OSEC, that is on-site hypochlorite generator system, was introduced. And in 1987, our first, the Iron Pure product was first commercialized as CEDI technology. We were acquired by US Filter. We established ourselves by US Filter as US Filter in 1990. And in 2004, we were acquired by Siemens. In 2004, we introduced Iron Pure LXHI model, and in 2007, we introduced Iron Pure VNX EEX model to the market. In 2007, Siemens acquired SG Lab Water Systems, and in 2008, Biomag Magnite Ballaster treatment was introduced in the market. In 2014, AEA investors acquired Siemens Water, and we established ourselves as Evoqua Water Technologies. And in 2016, Evoqua acquired Neptune Benzene, which is a leader in aquatics market. And in 2017, we listed ourselves in New York Stock Exchange. In 2018 and 19, we acquired Pacific Ozone Technology and ATG UV technology, and introduced. And by 2021, we introduced ATG UV VX VT and Pacific Ozone Powertron, these two new products to the market. This is the complete evolution of Evoqua in the industry. Moving on to explain about how Evoqua functions. Evoqua has got two key sectors. That is one is integrated solutions and service provider, and another one is applied product technologies. Integrated service solution providers are mostly into the customer facing project and services provider. And APT is focused primarily on sales through indirect product channels and channel partners. We are diversified, and we almost cater to most of the industries like healthcare and pharma, food and beverage, light and general manufacturing industries, microelectronics, drinking water and power, wastewater technologies, aquatics and pools, refining and chemicals, and commercial industries. And we are committed to sustainability, and we want to positively impact the human health and wellness in everyday life. Our offerings are aligned with the United Nations Sustainable Development Goals, and this allows us to help our customers create a more sustainable future. We are serving to we are serving to we are serving to most of the market in around the world, with Evoqua's headquartered, which is based out in Pittsburgh, Pennsylvania. We have 100 plus offices in US, which includes the plants and factories as well. And we are operational in 10 countries, and that includes Australia, Canada, China, India, Germany, Italy, Singapore, UK. And we have opened our India Technologies Engineering Technology Center in 2019. So this is how we are serving to a large, growing, and fragmented market. So starting with Iron Pure brand, which is a continuous electrodeionization product. We have supplied this product to the brands like Samsung, Toyota, Toshiba. Our Chloropack, which is sodium hypochlorite generating system, has been supplied to Tata, ONGC, and Shell kind of brands. And Balazan Tiernan, it's a which is a gas-free product and is active and trusted brand of chlorinator in India for over more than 25 years. And Evoqua is almost approved vendor is approved vendor list for all the major end users and EPCs and contractors. ATG UV system, which is UV systems, is supplied to most of the brands like Petronas, Kane, Total, and Dong Energy. And Pacific Ozone is supplied to Coca-Cola, P&G, and Pepsi. Our lab water products, it has got 1,050 working stations in India, and we have got 100% territory coverage with reputed channel partners base. So with this, I'm just ending the corporate overview. I now request Mr. Pan Jiashing to take us to the Iron Pure brand presentation. Thank you.
All right, I'm going to take over and cover the CDI portion. I hope I have control over the screen. Suma, next slide, please.
Okay.
All right, I don't seem to have control over my screen. All right, hold
you
on
have
first.
control. Yeah.
Yeah, I think the reaction is pretty slow, but it seems I have control already.
Yes.
All right.
You have control.
All right, good. So I'm going to talk about CDI technologies. For CDI product, is a key product for microelectronics in power in pharmaceutical, in the whole of the APEC region in China, in India. We cover, I think, mainly for the micro E, and then followed by the power and pharmaceutical industries. So since 2005, for the microelectronics, all of the people is requesting for higher quality water. Silica is no longer the key or the criteria. It has since moved to boron requirements. So for the micro E people, they are also like going towards the chemical free that is in the UPW. That's because for safety is a very big concern that is in that plant. So in these days, in the early 2000s, there is the advancement of technology. So a lot of them are going to use the RO and CDI. It's being used in the UPW systems instead of the traditional mixed baits. Okay, so here is the evolution of the deionization. So in the 1970s, where we have the first generation, every one of them is going to make use of the ion exchange resins. So there is the cation bait, and then there is the anion bait, followed by a mixed bait. So all these three equipment is going to make use of a lot of regeneration chemicals, so it's not very environmentally friendly, and then I think there's a need for a lot of the wastewater disposal too. In the 1990s, there is a driver, for the need for reduced TOCs. So a lot of them all switch into the reverse osmosis. So in this membrane technology, it's going to greatly reduce the amount of the chemicals used. But still, after the RO systems, it goes into the mixed bait, and the mixed baits also need frequent regeneration. So, I would say that in the 1990s, the amount of the chemical consumption has dropped probably like around 50%. And then since the early 2000, there is the pre-treatment, there is the UF and the RO and the EDI. It has like meet the complete elimination of regeneration chemicals, and it also brought a host of other benefits too. Okay. All right, next slide. Let's see. All right, so what is CDI? For CDI, it stands for it stands for the continuous electrodeionization, where it's it's a water treatment of the technology that is going to remove all of the ions in the water with an electrically active media, that is the resins itself, and then it's going to make use of an electrical potential to promote all of the ion transport into the reject stream. All right, Suma, can you move the slides for me? Yeah, it's because the reaction is a bit too slow. Okay. I'm sorry for the wait. All right, for CDI technology, it started off that is with the ED process. So for ED, it stands for electrodialysis. So in the ED cell itself, there is the alternating, there is the anion membranes and the cation membranes, okay? And then all these are special membranes that only allow cations to pass through or the anions to pass through. So all of these membranes is impermeable to water. So when I'm speaking about these membranes, it's different from the outer membranes, okay? For EDI membranes, only allow the ions to pass through. And then all of the water, it will not pass through. So all of the salts is going to transfer out of the product stream. It's going to be trapped in the reject stream. So for the ED process, it's not effective at producing the high quality water. Its principal use is just for like desalting the brackish water, and then it's also for seawater desalination too. All right, and then change from the ED process into the CDI process, all that we did is to add in resins into the module itself. So now I think there's a combination of the membranes, and then there is also the resins too. So all these resins is very, very conductive. It's going to promote all of the ion transport into the reject stream. And then it's going to require a special cell to contain all of the resin. So if you see the picture on the top left-hand corner, so for that one, it's called a spacer, where it's going to hold like the resins, and then surrounding it, there is the membrane seal, there is the O-rings itself, where after that we will send it into a bench press where it's going to clamp tight so that it can handle up to like 100 psi of the feed. So for CDI, it has been referred to as an all-field cell electrodialysis. All right, so here is a moving diagram, of how a CDI works. If you see on the right hand side, it's actually a 3-cell spacer where there is resins in all of the module. So as water starts to flow through the module itself, it's going to be put, all of the cations and anions is going to be put into the reject stream, where in the middle stream, there's going to be the product water, where that one is going to be the high purity water. So when the EDI is trying to clean the water in this way, all of the resins inside is going to be exhausting. Okay, but at the same time, in the model itself, there is the water splitting process where there is like the magic that is going on, where the water is going to split up into the H+ and OH- ions, where it's going to continuously regenerate all of the resins at the same time when it's being used. Okay, so instead, of trying to make use of the real acid and caustic, okay, so what happens in the module is that the water is going to split up, and then the H plus is going to be like the acid, and then the OH minus is going to be like the caustic. So for the EDI process, that is a truly chemical-free continuous process. All right. So when we have that of the continuous process where there is a continuous regeneration, on the right-hand side, if you see the diagram, for EDI, it's going to deliver a consistent performance, consistent quality, consistent flow rate. All right. So if you were to make use of the conventional mixed bed system, as we know, it's a batch production, there's a potential breakthrough. So at the point of time where it's going to break through, so what's going to happen is that, the feed on the product side is the water quality, it's going to dip, there could be a breakthrough of silica, of sodium, or in terms of the resistivity, it's going to be too low. So at that stage, the current mixed bed, it must be stopped, and then for the standby unit, it must kick in to continue its water of the production. All right. So for CDI, for CDI itself, right, it can actually exceed, the quality of a mixed bed DI. That's because in a mixed bed DI, in sometimes there could be poor or the regenerations. There could be some losses of the high purity resin in the mixed bed. That's going to result in a short vessel run. All right, and then CDI modules, there is special ones, so in the IMPure brand, there is the normal grade of the CDI modules, there is the high grade of the CDI modules. So that is going to make use of special resins in the module that is able to achieve up to 99% or 99.8% of silica and boron removal. So in short, for CDI, there's going to be like no spikes. There's not going to be any breakthrough in any way. All right, next slide. All right, so let's come to a poll. As I've been speaking about the comparison that's between the mixed bed and the CDI modules, I would like to ask the people over here, spend some time. So how many of you is still trying to make use of conventional mixed beds in our UPW plant? That is regardless if it's in a solar cell plant or like a microelectronics plant or a power plant, So the poll is open, can you choose one that's a yes or a no? It's very, very easy. I would like to hear from the people, from the viewers on what is actually being used in the system right now. Okay. And I would believe that all these people that is attending the presentation would be trying to make use of an RO system. So if you know that for the RO system, it's a very good membrane system. It's very, very chemical free. So if you combine the RO and the EDI, it's going to be the perfect combination. All right. All right. So I can see that from the poll, there is 69% of the people that is still trying to make use of conventional mixed bed. And then there is 31% that is trying to make use of the EDI brand, that is regardless of like whichever ones that is in the market. So, for those people that is still trying to make use of the mixed bed, please try and listen more. I'm going to like talk about like more of the EDI systems. Okay, so next slide. All right, so I'm going to come into the major cost components of the EDI. For the EDI itself, the major cost components is going to be like labor, it's going to be like resins, it's going to be chemicals, there's going to be like wastewater. So a big bulk is going to be chemicals and wastewater. But for CDI, there's only labor. There is minimum labor, okay? And then there is module replacement that is once every 5 years. There is the consumption of a DC power. And then there is also a requirement for some of the routine maintenance that is like CIP cleaning. That I would say typically in microelectronics, you know, as the pre-treatment is that's much better, it could be like once in 2 years. So mixed bed DI is a batch process that's going to require constant labor and chemicals. For CDI, you know, it's similar to the RO system. You know, it's a constant production process. There is minimum labor. All that is needed, there is the DC power, and then what is required from the operators that is on a daily basis is to record down all of the pressure parameters, the flow parameters, you know, and there's like the resistance of the module itself. So it's all recording, you know, and then there is going to be a bit more of the know-how, okay, but in terms of the labor and time itself, you know, there is actually very little time. So a lot of people, after trying to make use of the EDI, is going to say that, you know, I've got a lot of free time, so I make use of the free time and do something else in the plant. Okay. All right, so here is the major cost components. You know, if you talk about the cost in the EDI itself, still wait. All right, so as you can see on the left side of the diagram, for the main bulk, you know, of mixed bed, its operating cost is in terms of the chemicals, where it stands at about 57%. And then after you make use of the chemicals, you have got to send them into a wastewater treatment plant where it's going to be treated first before it can be discharged out. Whereas for EDI itself, its major cost components is actually that is on the CAPEX cost. You know, there's around 50% of the whole thing is going to be on the modules. And then after that, its main operating cost is only the DC power. As you can see from the numbers itself, its operating cost of electricity is much lower than if you were to make use of the chemicals. All right, so in all, you know, there is an OPEX cost savings of like around 50%. So for the people, for like the 31% of the people that have tried and make use of the EDI, you know, they would probably say that the purchase price is important, but it's not the number one. And then for its operating cost, it's also is extremely important too. That is because that one, you know, there is a constant fee that's going to be paid, you know, that is on a yearly basis. All right, and then on top of you know, of if you are trying to make use of mixed bed, you know, there is other factors where you need to consider. You know, there's like the employee safety training, there must be some of the safety showers, there must be containment equipment, and then there must be all of the chemical storage. As you know, if you store the hydrochloric acid or like sodium hydroxide, you know, it's extremely hazardous. So all of these places to store these chemicals, you know, it must be really well done. So there is a lot of maintenance to them too. And then on top of that, you know, in order for you to have an on-site of the regeneration for mixed bed, you have to deliver in all of the chemicals. So there's going to be other factors that is going to come in place where, you know, there could be times where there's going to be heavy rain or flood, where like the delivery of chemicals, it will not come in time. But if you use the CDI, you know, it only is going to require that is only the DC power, where, you know, in terms of its operation, it's going to be more stable. There is less of the other factors that's going to come in. In terms of floor space comparison, you know, of course, if you have a CDI, you know, it's going to be much more space effective. Okay, and then in fact, you know, if you increase on its flow rate, if the system size get larger and larger, you will see that the CDI is going to have a lot more floor savings. Okay, and that is because for CDI is able to stack on top of each other. All right, so so I'm going to show you in a few pictures that is later, on how CDI skids are being installed. And then from there, you can see that, it's actually is very, very space savings. Okay, so here is a quick summary, of why like the Micro E is going to choose CDI that is over the mixed bed DI. So I think most importantly, there's no chemicals. There's, there is no downtime. There is very, very little downtime. It's a consistent performance. It's guaranteed leak-free up to 7 bar. There is superior safety. In terms of the footprint, it's very, very small. In terms of its cost to operate, it's much lesser as compared to the mixed bed DI. There is a reduced labor, so it means that the operators, it can do some other things too. All right, and then for CDI, it's a continuous process, it's not batch. And then there is a complete reduction, of health and safety risk. All right. So my next slide. All right, so here we are at poll number 2. I'm gonna spend like some time over here. Just gonna ask a few questions on what is the most concerned factor when it comes to equipment design in the UPW plants. So please open up the poll, and then there's going to be a few things where there's going to be like safety. Is safety a concern for you? Is footprint a concern for you? For like plants that is currently trying to make use of the mixed bed, I guess probably the footprint is very concerning to you. Is low CAPEX cost and low or the OPEX cost important? And would you like your plant to be all fully chemical free, or like all of the above? Okay. All right, so I can see that all right, it's still 33% of the people has voted. So let's wait for a bit longer. All right, so we have 60% of the people that has already voted. All right, so I'm just going to share on the results. There is 5% of the safety, and then there is 11% on footprint concerns, and I think there is 37% on low CAPEX costs and also its operating costs. There's only 5% that wants it chemical free, and then there is 63% that is saying that all these things is very, very important to them. All right. All right. So let's move on to the next slide. All right. So here is a very typical setup for like microelectronics industries. It starts off with the pre-treatment. And then it goes into there is like a dechlorination system where people is going to use the that is the ACF or like the sodium bisulfite. And then after that, there is some of the anti-scalant where it goes into a 2-pass RO. It feeds into an RO permit tank. After that, it goes into a UV TOC and then into our CDI module. So a lot of plants like solar plants is going to make use of a UV TOC, and then for like our Zalin brand also, we have our own brand of the UV where it's called the ATG brand. So the presenter later is going to talk more on the ATG model. All right. And then after the DI, it goes into the DI storage tank where that is the end of the makeup loop. If you are in like the Micro E sector, where it needs to have like around a super high of the quality of water. And then after like the DI storage, it goes into the polishing loop where it's going to make use of a non-regen resins. Okay, there is still resins, okay, but it's actually there is a non-regen resins that is for like treating the high purity water. So in that sense, there is no chemicals that is needed to. And then after that, it goes into a few more of a of like a degasifier and a UV TOC, and then for the ultrafiltration before it goes into the point of loop, into the point of use. Okay, so my next slide. Suma, can you move the slides for me? It's because I think it's a bit too slow and it's quite slow reacting. All right, so in the region itself, for like microelectronics, there is a few of the famous one that is like Samsung, and like Micron, or in Singapore, there could be like UMC, but then, all of the installations over here that I'm showing you is like solar installations. There is a few in India, there's like Premier Solar, there is Jupiter Solar. But in Malaysia, there is a lot of them. There's like First Solar, there is Hanwha Q Cells, there's Jinko, there is Longi Solar. For the First Solar, there is presence of them in Vietnam and also in Malaysia. And then in Singapore itself, there is the REC Group. So all these places is trying to make the solar panels, so it's actually, there is a growing industry, where a lot of them has converted from the mixed bed into the EDI. So next slide. All right, so in the CDI model itself, a popular brand that we use is actually that's called the VNX series. That is like a cylindrical kind of a module. It's very different from like the other brands where it's like a cube size. For the VNX series, it's actually round in shape. So it's actually that the spacer is round, where in between them there is alternating cat iron and the N iron, and then we are going to sandwich all of the resins on the spacer itself, and then at the very two ends there is the cathode and the anodes, and we will clamp them up into there is a form like a heat exchanger, and then afterwards where it's going to be housed inside the FRP housing, as a form of a cosmetic. All right, next slide. All right, so here is a picture, of like VNX kits that is throughout the world. So this plant is in Malaysia, it's trying to make use of like 9 of modules of VNX. So each module, is about 12 to 15 cubic meters per hour. So as you can see, for the total flow rate, is close to 100 plus cubic meters per hour. And then, it's a very small footprint, it's a very simple layout, and there is not a lot of the piping and instrumentation. Okay, next slide. All right, here is an example, where I'm going to show you a real case, of a solar plant. There's a Jinko Solar in Malaysia. So here is a comparison, of the LX module and that's versus the VNX module. So as you can see, for the LX modules, the maximum flow rate that is capable for each module is about 5 cubic meters per hour. So in order to meet up with the VNX modules, it needs to be like in a 3:1 ratio. So footprint size is a lot more, all right? And then there is going to be a lot more of the piping and instrumentation too. So on the picture on the far right, it's a combination of everything that is in one skid, where from the outer permeate tank, it goes into a cartridge filter. And then if you can see, I think there's a tiny picture of a UV TOC, and then it goes into the EDI itself. All right, next slide. Okay, and then in this picture is a picture of the solar installation. So here is a picture at the First Solar that is in Malaysia. So also all of them is trying to make use of VNX modules. It's very simple. It's done in PP piping. So all sort of piping it can be used. All right. And then for the next picture, which I'm going to show you. All right, next slide. Here is a picture at the Hanwha Q cell. You know, that's a pretty old system. We had that since like 2012 or like 2013. You know, so for this one, it comes in a bit more complicated. That is because the designer opted for a one-to-one design. Okay, and then on the right-hand side of the picture, there's a control panel. There is, you know, there is like a transformer box where it's trying to make use of our DC components. All right, so this one is the old style components where it's not being used any longer. So I'm going to show you in the next slide. That is the latest one that's called the DC3 controllers, where it's a special, where it's the latest type of the controller. See if I can get back to the previous slide. All right, where it's not going to need any form of a transformer. So for the DC3 controller, it takes in the three-phase from the factory source. It goes into the DC3 controller, where it's going to dish out a single-phase output straight into the module. So, you know, although the controller is slightly bigger, you know, it's quite big, it's quite bulky, but there is no need for transformer. So in terms of designing the control panel, it's going to be very easy and sweet. All right. And then at the far right hand side, there is a very simple HMI touch panel where the operator can set its operating current, and then at the same time where it can view its operating voltage and also the resistance of the module. Okay, so this is what is called as a local control, but there could be some of the designers or the users that want to have a that is like a remote control. So for our DC3 controller, you know, it's compatible with the analog signals of 4 to 20 milliamp. So if you want to control it from a control room or there's from a PLC, you know, it's also possible. All right, next slide. All right, so here is the evolution of VNX series. It's a very complicated timeline, okay, but I'm going to quickly summarize all for you. You know, if you see on the lower left-hand corner, it's all of the part numbers, and then all these wordings in red, okay, it's being discontinued. So throughout the years from 2004 until like around 2023, there had been a lot of improvements on the VNX module, and it's all from the feedback of the people that is trying to make use of them, and it's also from like the users itself. But I want you to focus on the numbers. Okay, so if you see on like the bottom left hand side, there is the VNX 50, there is the VNX 25. So these numbers stand for GPM. So it's either 50 GPM or there's like 25 GPM. And then in 2014, if you see on the lower right hand corner with all those words in black, from 50 GPM, we have improved it to 55 GPM. Okay, in the same exact of the FRP housing, we tweak around the spacers, you know, and we reinvent the spacers and try and make it and hold a bit more of the volume. Okay, and then until now in 2019, you know, on the far right hand side of the timeline, there is the VNX Max module. So this one is the latest module and the highest flow rate module. It goes up to 66 GPM of the nominal flow rate. Okay, if you are talking about the maximum flow rate, it can go up to 100 GPM. And then on top of that, it's not only that we improve on the flow rate, we also improve on the performance of the module. In before, you know, on the left hand side, that is on the blue line, is all the standard modules, that is all of the normal modules. You know, in 2016, we converted our normal modules and we tweaked the resins in the module and we make that into the EP modules. So EP stands for Enhanced Performance Modules. So it means that in terms of the power consumption, in terms of the quality that's coming out in the product is much, much better. Okay, and then that is only our standard modules. All right, in 2015, we improved our standard modules to a microelectronics one, that is the E and the EX modules. That is mainly targeting the silica and boron removal. And then in 2022, for the people that has been to Singapore for the Singapore Water Week, they would have seen that is at our booth that we introduced the new product, that is the VNX Ultra. So this one is the highest and the best performing module that we have at the moment. It's capable of removing up to 99 that is around 99.8% of silica and boron. All right, so it's mainly for people that's like Samsung or like Micron, or people who want all of the silica and boron levels that is in the PPT levels. Okay. All right, let's move on to the next slide. All right, so here is just a diagram, that is to show you that from the past until now, on how we improved that's our VNX modules. In 2004, it's like 3 stacks in a module. All right, it's not, it's all hidden inside the FRP housing. Okay, but actually in a VNX module, in before, there's like 2 or 3 stacks. All right, and then in 2018 we have the VNX Max, and then for the VNX Max, it's a single stack module. It's the highest flow rate, and then in terms of power consumption, is because it's a single stack, it only runs up to 7 amps, and then in terms of the GPM per footprint, that is the biggest. And then if you stack a few of them up together, it's going to be that is going to run up to a lot of flow rate. Okay, next slide. All right, for VNX comparison, there is 3 columns. There is the standard modules, there is the EP, and then there is the EX and the Ultra. So what I want you to see over here is that, even though, if you see the EX and the Ultra, the feed water requirements is actually pretty low, all right, it's less than 10, okay? But then if you have that, and we will guarantee you that's going to have like more than 17.5 mega ohms of the product water. All right, and then in terms of the recovery for EX and Ultra is much higher, up to 97.5%, and more importantly is individual of the ionic removal is much better. Okay, and also just to let you know, for the VNX Ultra, it's actually equivalent to a 2-pass EX module. All right, for the EX is up to 99% silica boron removal, for the Ultra up to 99.8%. Next slide. Suma, can you help to move the slides? All right, so here we are at the flow comparison. There's the 50 series, there's the 55 series, there's the VNX Max. I've already explained slightly earlier. It went from 50 to 55 to 66. So what's interesting in this slide is on how we try and design the modules. Okay, so for our 55 series, it has been in operation since around 2013 until 2023. So there is a huge installation base of the 55 series out in the field. Okay, and then a lot of them, they want to increase its flow rates, at the same footprint. So all they do is to replace the VNX 55 that is with the VNX Max. Okay, it's exactly the same kind of the module. There is the same resin configuration, there is the same performance, only that the flow rate is much higher. All right, so if you change one piece into the VNX Max, it's going to be like around extra of the of around 10 GPM. So if you have a skid of 5 or 6, that is equivalent to getting an extra module, that is in the whole skid itself. All right, and then in terms of the replacement process, it's very straightforward. There is plug and play, and we design all of the piping connections that's going to be exactly the same. So there's no need for you and do any form of the piping modifications to your existing skid. And then if you notice that, for its operating current, that is like half of the 55 series. And then at the far right hand side column, there is also the VNX Mini. For the Mini, it's also a single stack like the VNX Max. It has similar flow rate that is with the 55 series. But if you notice on the module length, okay, so if you have a footprint crunch, a good option for you is to try out the VNX Mini. That's because it's slightly shorter at 1.7 meters long. Other than that, all of this, have exactly the same performance. Is because all of these are our standard modules. All right, let's go to the last slide. All right, so that's the last slide. So in summary, for VNX series, is the highest flow rate module that is available in the market, and there is no other competition that is holding on to this technology that has our kind of flow rate. And then for VNX series, it's a very simple building block. If you see from the pictures, its piping, and its instrumentation is very, very minimum. And we have the EP performance that is suitable for back end of the microelectronics, for solar plant, for power applications. All right, and then in every region itself, we have technical support, and then in the India region, there is data. There is always people that is stationed in China, in South Korea, and then for me, I will look after the whole of the APEC region. So, if you use our modules, if you have any questions, that's where we will come in and we will try to help you and answer all of the questions. And then if you head into our main website, that is the Xylem website, there is the IP Pro software, where it's like a projection software for you and estimate on what is the product, that is based on the feed requirements. And then after that, there is also a support button where if you key in on whatever things you want, there's like PNID drawings or like data sheets or manuals, it's going to pop up. So even without the local tech support, you can get all of this information, okay? But if you have anything in specific or if you can't find it, okay, please look for your local regional support people, okay? And then if you sign up, there's going to be a regular newsletter, that is going to be a few more of the exciting new products that is going to come up in the next few months. All right, I think with that, that is the end of my presentation. If there's any questions, that's going to be at the end of the whole 3 presentations. All right, so I'm going to pass the baton back to Suma.
Thank you so much, Pan. It was really interesting presentation and hearing from you. Now, I would like to call upon Mr. Samir Dasani to take us through the UV presentation. Samir, over to you.
Yeah, thanks, Suma. Thanks, Pan. Suma, can you go to next next
Yeah.
slide, please, Suma?
Samir, we would like to, can you switch on the video?
Yeah, but actually network is slow.
Yeah. Okay, no problem.
Hello, everyone. Yeah, next slide, please.
Yes, yes.
Hello, everyone. Myself, Samir Kusani. I am uh, Associate Technical Sales Support Engineer, looking after the ATJ UV part. Now we can see today here what is a UV and how does it work. So basically, the disinfection UV is for use for mainly for disinfection, ozone destruction, and TOC removal. So now we can see here the one diagram here, the UV range. You can see here the preliminary UVC, UVA, and UVB range are available, but basically UVC range are operate from 200 to 280 nanometers. So the, the process is that the photons absorbed by DNA in microorganism leads to inactivate the microbiological microbiology in the water. So basically, it's only inactivate the microbiological things in the water part. This is the process actually the UV works. Suma, can you go to the next slide, please?
Hmm.
Now we can see here the two types of UV systems here, and according to differentiate on your on UV lamp. So basically, there are two types of UV systems. So we can call as a low pressure high output amalgam and the medium pressure UV systems. So differentiate between the low pressure is that the inert gas fill in the UV tube is in low pressure at below the atmospheric pressure, and in medium pressure UV systems the gas fill in the UV tube is up to the atmospheric pressure. This is the major difference. And in terms of the wavelength, the low pressure UV system we can say as a monochromic wavelength, and medium pressure uh, is a polychromatic wavelength. We can see here the low pressure UV systems at higher electrical efficiency than medium pressure, and medium UVC output per length is required. And we can say that in terms of efficiency, the efficiency is a more low pressure UV system is more compared to the medium pressure UV system up to the 35%, and 35% visibility, and 30% is the intensity of this UV system, and it's required a very large footprint area compared to the medium pressure systems. Okay, now we can see here that lamp power range available in the market. We can say 100 watts to 1000 watts, and if for medium pressure 400 watts to 30 watts up to the 30 kW. We can say here the efficiency, and we can just discuss 30 to 35%, and the medium pressure 10 to 15% and typically the lamp life in hours we can say it's up to 8 to 14 hours for low pressure UV systems, and for medium pressure is 3 to 8,000 hours of medium pressure UV systems. This is the technical difference between the low pressure and medium pressure UV systems. uh, Suma, can you go to the next slide please? Now we can see here the core benefits of the UV technology and what are the advantages of this UV systems. The effect each UV system is effective against the wide range of microorganisms, including the cryptosporidium, giardia, and its advanced capability to fight microbiological populations that are developing tolerant to the chemical and low heat, no heat. And it's very high efficient technology, and to reduce your capex cost also. This is the major difference, and we can say in terms of the safe and control systems, you can you don't need to do storage if specific storage is required. The handling is very simple. You can transport from anywhere, and it's no toxic and no corrosive chemicals required to operate this UV system. It's very easy to use. It's a retrofit design. It's easy to install, and you can change the lamp in 1 or 2 minutes. It's a simple maintenance, and the reduce your OPEX costs also. And most important is the sustainability. In terms of sustainability, the reduce the use of chemical of environmentally, and personal safety also. Yeah, this is the major core advantage of the UV systems. We can see here. Suma, can you go to the next slide? Now, what parameter is required to design the UV system? So we require the flow rates, water quality, the water quality in terms of the UV transmittance, what are the TSS level, turbidity, or design or organics present in the water, if any color or any metal concentration available. These are the parameters required for the design the one UV systems. If in terms of disinfection or any log reduction, we can say the 2 log reduction, 3 log reduction. 3 log means 99.9 percent, 99.99% log reduction. The plant hydraulics redundancy required, and for the TOC system design, we require the inlet and outlet TOC in PPB. These are the basic parameter required to design the UV systems. Suma, can you next slide please? Now, where we can use this UV, you can use UV system anywhere where there the any process that the chemical intolerant, or where we can say the chlorine resistant microorganism You can use this UV system from all over the industries, from wastewater treatment and reuse for drinking purpose, pools and water papers, irrigation purpose, and most important, electronics and pharmaceutical, automotive. Anyway, any industries you can use this UV system. Oh, yeah, Suma, next slide, please. Yeah, we can see here the how much do UV dose is required to in respect of the bacteria and the virus. If you see here, the E. coli, Pseudomonas, and Legionnaires is up to 30 to 40 millijoules. Is sufficient to inactivate the microbiological things, and protons. It's again say we can say up to 30 millijoules is required. But the virus, adenovirus, we can say up to the 200 millijoules per centimeter square. The a very high dose is required to inactivate the viruses from the water or anyway of this contaminant in the water. Yeah. So this like yeah, this is one simple the pole here. We can say here. What is the wavelength used for the TOC reduction in UV system in ultra pure water? Now your pole start now. It's you can see here 20% people are saying 253.7, 33 people are saying 185, 42% are people are voted, 48 check with 5 to 10 seconds. Okay, now 61% voted. Now we can see here the poll. The 21% says that 253.7, 32% 254, and 32% says 185 nanometer. Actually, the 185 nanometer is the correct answer. Or maybe, theoretically, 185 nanometer is required to inactivate the to reduce the TOC from the ultra pure water. We can discuss later on this presentation how it's work TOC reduction mechanism. So, Mark, can we go to the next slide, please? Yeah, we have a ATG UV system, and we have a one model for TOC reduction for VT series. We can see here ATG UV is around 40 years of UK based company. All the manufacturing facilities in UK. We are lots of installation globally about last 40 years. So, yeah, Suma, next slide, please. Yeah, these are the range available with us for UV systems, from low pressure to the high pressure. Sorry, medium pressure. The VXVT used mainly for pharmaceutical and micro industry. UVLX for drinking water purpose, municipal. Wafer system where we require the small footprint area or any complex in the or any area constant. You can use the wafer or SX series of these UV systems. Yeah. Suma, next slide, please. Yeah, these are the product range we are discussed earlier, the low pressure to the medium pressure. The ATG brand name called in APEC region and EMEA region, and for North America, the ATG UV system is called as a ETS UV systems as a brand name. Globally, we can known as a ETG and ETS. You can see here the low pressure system. Our range is available from 1 lamp to 32 lamp up to the 32 lamp. UVLX up to the 45 lamps. Wafer series systems up to the 12 lamps, and SX series 18, and followed by UVM series for dechlorination TOC purpose for 8 lamps. These are the variables, different types of lamp combined with the one UV system ranges are available in our UV product portfolio. Yeah, we can use any application. So my next slide. Yeah, this is the UV treatment and what are the component installed for the UV system. If you see here, the sandwich, the UV system in gray color pipe. These are the very small footprint area required for the wafer type UV systems. You can see here the one control panel, UV sensor, and the wafer wiper here uh, for to cleaning the cord sleeves from the inside the UV systems. Yeah. Suma, please next slide. Hello. Yeah. Now we see here the VT range of TOC reduction UV systems in for ultra pure water. These are the, we can see here the product, what are the products available. Yeah. Suma, next slide, please. This is the typical photograph of the TOC reduction UV system. You can install multiple UV lamps inside the UV system. These are UV core TOC ATG family products designed for supply superior TOC reduction in ultra pure water application and microelectronics and solar industries. Yeah. So my next slide, please. It is a particularly designed for the TOC reduction. It's mainly yeah. So my next slide. The transaction may be the slow. Yeah, this is the, we can see discuss earlier. Earlier slide, please. Previous slide. Yeah. This is the TOC mechanism. Uh, when the while the most organic compounds are decomposed to the CO2 and H2O, other more resistance to molecules and a weakly charged ion resistive. If you go to the, it and goes to the resistivity drop, the removal facility by downstream of the DI and ADI systems. If you see here the diagram, the TOC plus 185 nanometer, it break into the H2O plus CO2 get released from the water. These are the mechanism we can theoretically to theoretically you can say that reduce the H2O sorry CO2 from the water. Now, which is such high voltage, this application will essentially blow the bacteria apart and break it down into the CO2. And it's a single bond and easy to break. The TOC and most importantly, the TOC system is dependent totally 185 nanometer constant output of the UV systems. Yeah, this is the mechanism we can say we can discuss. So my next slide, please. Yeah, this is the same mechanism of what we discussed. One H2O plus 185 UV and goes to H plus OH plus ions goes, and it's a reduction of formalic acid, HCOH plus OH and CO2 and H2 get released. Yeah. So my next slide, please. Yeah, this is our VT lamp. We can say see here is a key and efficient UC reduction unit in ultra pure water application in maximum up to 25 nanometer TUC output. If you see is below here the high levels of 185 nanometer, you can see 185 nanometer is a spectrum in terms of spectrum. It's point to the power energy is required, but if you go to the 254 nanometer UV system, the higher power is required to operate this TOC reduction UV systems. Very high dosage and very high power is required. So this is the simple thing we can discuss here. And our VT lamp is a finest grade material lamp, and it's we can say a longer life up to the 16,000 hours. And it is and it's available with the 300 watts of UV lamp systems. very high power of compared with the others. And due to the high power, it's a total number of lamps is less numbers of lamps required for the higher flow rates also. Yeah, Suma, can you go to the next slide, please? Yeah, this is the one example or diagram where you can install the UV systems. If you see here, the after the RO storage tank, you can see the primary DOC reduction from say 500 to 150 ppb, and the polish unit you can say the 50 ppb, sorry, 50 ppb to 5 ppb. You can install like that for the DOC reduction in ultra pure water. Next slide, please, Suma. Yeah, this is we can discuss semiconductor, where we can use the very high ultra pure water type 1E water is required to the for solar industries. So you can see here the less than 1 ppb water is required to the wafer to reach the wafer of the semiconductor device. This is the major advantage of the UV systems. You can, it's a grafer. You can, if you use this water, you are greater the wafer yields, and the switch into the smaller chip geometry, such as 0.07 microline per width. It's a very high performance UV systems we can offer you compared to the others. So my next slide, please. Yeah, the VT range we have currently we have a four models start from 4 lamps to 24 lamps. In terms of flow rates, we can see the 5 meter cube per hour to the up to the 120 meter cube per hour or 125 meter cube per hour systems. We can say from reduction 500 to or whatever as per your requirement. The VT series 4 300 6, it means in terms of 300 is a lamp power. If you see here, the power consumption required for the UV system from 1.2 kW to 7.2 kW, and it's available in various end connections also. Yeah. So my next slide, please. Yeah, you can install the UV system at horizontally or vertically. Sorry, or horizontally only. This is the flexible installation and with small footprint area required. This example of your 24 or VT24 model you can see here. Next slide, please. Yeah, if you compare with the Aquafine, in terms of flow rate, we can see here the very small flow rate. The four numbers of ATG UV system it is required, but for smaller flow rate, it's 8 numbers of lamps required. Is the reason behind this is we can offer you the 300 watts of UV lamp, but Aquafine offers the 175 watts of the UV lamp. This is the difference we can see here. The for higher flow rates, they are double of the UV lamps required. It means your higher the CAPEX and OPEX costs also compared to the ATG UV systems. Yeah, Soma, next slide, please. Yeah, this is the for some reactor features we can offer you is a simple twist lock design mechanism, and it's a V-lock clamp design for leak-proof design. You can change over the UV system, change the lamp from the UV system in hardly 1 or 2 minutes, and it's in a running condition also. This is our patented technology. We can offer you of the UV systems. Suma, next slide. Yeah, this is the some reactor features. It's as per the requirement of the ultra pure water requirement. We can see here the lamp life available is a 16,000 hours for 300 watts of UV lamp. It's a twist lock design. The internal and outer surface available at 0.4, 0.4, 0.8 RA. If you require electro polish or mechanical polish, machine polish is also available. It's a UV system is a variable, most important, a variable power controller. It's a yeah, operate depend on your flow rates or your UVT 60% to the 100%. It's automatically auto-based dosing systems. You can reduce the your powers and power of the UV system. Yeah, this is the some features available of our UV systems. And this is the one controller. We can say the microprocessor based controller. You can configure with your Modbus and BMS systems, and you will get all this data from this microprocessor touch panel UV system uh, from your remote location, and you can operate from your you can see the what are the parameters and what are the current or all these things you can check with your mobile and your tablet. The only thing is the equipment connected to the internet. This is facility also available in our Spectra control UV control panel. Yeah. So my next slide, please. Yeah, this is the Spectra controller range. The standard and options are available. In terms of the material, we offer you the standard is epoxy mild steel 7035 color. Stainless steel SS304 option is also available. It is a microprocessor based control panel. The ingress protection, you can say the IP54 and IP56 also available for outside application. It's environmentally controlled with the for we can install the force air cool fan for ballast cooling uh, for this UV systems. The communication port available RS422 and RS485. It's a door lock MCB isolator and operating temperature up to 40 degrees centigrade. We can share with this our product catalog or available with our website. Yeah, Suma, can you go to the next slide? Yeah, this is the control units we can available in our microprocessor based control panel. You can display information. If you see here the what are the lamp running condition and how much hours the lamp current, the how many strikes per day, the lamp fault information. If the lamp is break or the cord sleeves are break, the information goes to the system and system gets start stop in any fault condition. The analog input you can see available UVT meter or flow meter you can also configure of our UV system. And as we discussed, the communication protocol both are available, and DP Profibus DP is also available, but it's not but it is a non-standard panel. Optional, we can offer you. So next slide, please. Yeah, this is the digital inputs and outputs. You can configure accordingly as per your process requirements. The three digital inputs you can remotely start, stop, power boost. You can connect with the UV panel according to your water level tank. You can reset alarm, process interlock. You can also available, and output is a temperature alarm, remote control, a dose healthy. If the dose is not healthy, then you will get details on your UV systems. All these digital outputs can available in our UV systems. Suma, next slide, please. Yeah, as we discussed earlier, uh, the data you can see here, the data log is available, and you can get all this data to your remote location by Profibus or Ethernet connectivity or any web access like dosages, how much UVT power, lamp hours, lamp current. All these data are stored in a microprocessor based control panel, touch panel. You can access anywhere from the you can access anywhere. Yeah. So my next slide. Yeah, this is the simple architecture for microprocessor based control panel. The membrane with OLED touch display panel or a 7-inch touchscreen also available for higher model. The SD card, all the data stored in the SD card. You can remove the SD card and check with the data. The SD card connected with the motherboard and a touch display panel. And this is the electronic ballast connected to, and the motherboard operates to the electronic ballast of variable power controller system. Suma, can you go to the next slide? Yeah, we now come to the some benefits of this UV system. It's a major benefits is a higher efficiency and lower OPEX cost for 185 nanometer tubes reduction, and higher lamp hours. We can offer you up to the 16,000 hours. It's very simple and easy to use technology uh, of this UV system. And we offer you that, as discussed, the twist lock design, V lamp design, and most important is very variable power control system, turn down ratio up to the 30%, depends on your flow rates or the TOC uh, of the water. Suma, next slide, please. Then there's some transaction there. Hello.
Yeah, just a second. Am I audible?
Yeah, you are audible. Can you go to the next slide, please?
I think it's, yeah, I've gone to the next slide. I think it's not visible at your end.
It's not visible. Yeah.
Yeah.
Okay. Yeah, so some certifications, validation certificates, our UV systems as per validation drinking water, USEPA, EPA, and UVTGM. It meets all the FDA grade requirements for food and beverage industries, for NWRI for the Norway guidelines, NWRI reuse guidelines, NSF approved. These are the certifications are available with our UV systems. Yeah, Suma, next slide, please. Hello.
Yeah, yeah. I've gone to the next slide.
Yes. I think the last slide is, I think, like some case studies and installation photographs where we can install. Can I switch off my camera? Then the transaction will be more faster. Can you change the slide?
Yeah, I've changed the slide to the case study slide. It's waiting for the next screen. Connection, just a second. Weak connection.
Now, okay. Yeah, these are the some case
Yeah, one
studies
second.
where we
Yeah.
we are installed in globally. The location Thailand, we are installed UVLA for food and beverages market in 2021. In Singapore, VX model is installed for biomedical purpose, and in Singapore, it is skid-based UV design system for aquaculture purpose. Yeah, these are the case studies we can discuss. If you have any doubts or if you want any question, you can write me on this question and answer session, or you can write me on after this on my email ID, or on the product data catalogs and technical details are available on our websites. Okay. Yeah. Go. Yeah. Over to you, Suma.
Yeah.
Thank
Yeah.
you everyone for your patience.
Thank you so much, Samir. It was a really nice presentation and very informative. Now I would request Mr. Dattatreya Patel to take over the WAF automatic screen filter presentation. Mr. Dattatreya Patel, over to you.
Yes, thanks everybody. Good afternoon to all. We'll discuss. I'm the Dattatreya Patel. I am looking this sales and service support for this Asia, South Asia region. So today we'll describe about one of the one Evoco product, that is WAP. That is, we can say it is automatic self cleaning filter. And basically this filtration, it is manufactured in USA, so it is made in USA. So next slide, please. This is a general arrangement of that WAP filter. Next slide.
Filtration technology landscape.
Yeah, next slide.
I've
Yeah,
moved on
so
to
this
next
is
slide.
yeah. So this is filtration technology landscape. So you can see it is what is the particulars available in the water and what the technologies are available in the market. So basically this from centrifugal separator to screen filtration, media filtration, back filtration, cartridge filter is the technology available. So accordingly the particle size, we will choose this filtration system. So these are the particulars available in the water, like that human hair, some plant hairs, beach sand, some like that. So accordingly this type of particulate we will design or we will consider or propose this technology. So out of that one, that is a screen filtration. So we will discuss in the detail, that is a screen filtration, automatic screen filtration. Okay, next slide.
Yeah, just
So
waiting for the
this,
next slide. Yeah.
yes, so this is this is the one example, or this is how install this is the one example where how to install our WAP filter, WAP automatic screen filter. So it is very easy installations, and it is doesn't not any major control like that. So it is automatic working, and we having the control panel also, but this is inlet outlet simple flange ended, and having some controls and some flush line. So this is one of the example in power plant. Okay, next slide. This is another one example where this is a WAP filter where it is in agriculture purpose. Next slide.
I mean, next slide.
So history of this product is that 1985 the screen filter was introduced by our one US distributor, and is named as that's automatic self clearing filter. In 1995 the standard manufacture started the manufacturing type, that is piston type, some electrical type. So screen called that is WAP 200 series. Then 2003 introduced as a new patented, and which is introduced that our nomenclature that V series automatic screen filter. So in 2016, and that automatic screen filter having more than 11,000 installations around the globe for the various applications. In 2016, Evoqua acquired this WAP filter from 2016, and we having one new facility open in 2020. Okay, so market application, that is one the major market application for this WAP filtration, that is cooling water and HVAC. So commercial offices, facility, hostel, industrial process, we say it is river intake system, you can install our system. Then irrigation, oil and gas treatment, pre-treatment for membrane, this is for semiconductor or solar application, we can use this filter for pre-treatment for membranes or ultrafiltration. Then again municipal and building intake also you can use. Next slide. Next slide, Suma.
Yeah, I'm in the next slide.
Yeah, so as I told, that is 11,000 our installation is worldwide. This is a map where we can see the installation is there, and you can also get the details if you want. So next slide.
Yeah, there is a poll question.
Just a minute, but next slide. Yeah, so this one of
Yeah.
the poll question is that you can just poll or vote it, that is what type of the pre-treatment filtration system is currently used in your ultra pure water plant. Okay, so your poll is start now. So there are three options,
Just
that
a
is
moment.
conventional sand filter, any screen type filters, or others. Okay,
Yeah, close the poll
so
questions.
yes, so just okay, so next
Yep.
slide please. So this is automatic screen technology, how it works. We just are explaining this video. Some please next slide. Next
Yeah,
slide.
it is coming. It is processing.
Patilji, can you please switch on your camera? Then the transaction will be maybe more faster due to the low
Okay,
connectivity.
no problem. Next slide.
Yeah, just a second. It is waiting for next screen. Just a second.
Yeah, so this is a one video where you can see this is filtering mode, how it is filter the water in normal mode. Please start the video.
Yeah, it is started.
Not started. You click it here.
Yeah, I've clicked it. Starting.
Not started. Okay, let's
Not
try
yet?
once
Okay.
again. Yeah, let's try once again. Otherwise, move to the another slide.
I cannot. I'm in live.
Yeah.
Yes.
So this is the filtration mode, but it's not running continuously.
Yeah. Now it is fine, Dadari. Now it's fine. Yeah.
No, just started, but again it stopped. Okay, you can move on second filtration mode slide.
Okay. Now it's fine. Now it's fine.
Still not. A little is coming, but it's not movable. Okay, so this is the filtration mode. This is simple filtration, is the media in between. So water coming from the right to left. So right is the your inlet, and left is the this outlet, and in between the filter is there. So just they removing or just accumulated the all particulates. This is a simple filtration mode. Okay, next slide please.
Yeah. Next screen. I have gone to next
Next.
screen. Screen filter. Reverse flow flushing.
Yeah, but it's not showing here. Still it is filtering mode. Video is there.
Fine now.
No, Soma. You can stop this video first, then I think you go to another slide. It is showing still it is running this video.
Okay. Uh, okay. Now I think it should be fine.
No, you not no Soma. Just you close or stop this video and go to the next. Otherwise, I will start. I will give the access.
It.
Okay,
Yeah.
please
I'll
give
give
me
you
the
the
access.
access.
Please
Yeah. You have the access.
give keyboard and mouse control. Correct, na?
Yeah. Yeah. So you can operate it from your end. Yeah.
It's
You are
not
in
here.
the screen. Yeah. Yeah. Now in this next screen. Yeah.
But it is showing same way.
Yeah.
It is not moving up and down now from
Now
my
it's
side.
moving. It's moving. That you can talk. Yeah.
Oh, but
It's
my
moving.
screen gets stuck. My screen gets stuck, na, whatever that video. Okay.
Okay. Now in the you're on the 89th slide. Yeah.
So
Yeah.
this is a sorry, actually some because of some technical issues.
Sorry for the
So
disturbance. Yeah.
yeah, this is the filter types, that is screen filter types. One is the piston scanners, single pass technology, electrical drive, which is also single pass technology, and third one, that is V series system patented by directional cleaning multipass. So this is the three technology available for cleaning this pre-filtration systems. Okay. So first one, that is piston scanner filter. This is the assembly. This is a simple, which is just a single pass technology, and which is operated by using a piston on off. Okay. This. So piston scanner filters have some benefits, that is lower cost, simple controls, agricultural drip irrigation. It is useful for this agricultural drip irrigations. And this having some disadvantage, that is no control suction nozzles movement, higher flush flow rate. They will take the higher flow for flushing. Doesn't work well at pressure of above 5 to 6 bar. And some we found that is some shaft seals leak also found. This is the disadvantage of this piston scanner filter.
Next slide.
Yes. So this is second one, electrical drive filter, which is operated by electrical drive technology, and which is again single pass filter. Next slide. So they having some advantage, that is the control suction nozzle movement. That means that the nozzle controlled by some this electrical works well up to 10 bar. They are having some disadvantages, that is high level of parts requiring some maintenance, gearbox screw requires lubricant, electrical motor limit switches require PLC control. By PLC it will be work finally. Body shaft leaks frequently, and some this is the material of cost, material of construction, that standard carbon steels. Next slide please. So third one, that is V series automatic screen filter. This is having 60 parts. So next slide please, click it. So this is the part main, this is your inlet, this is the outlet. They having the main core screen. It will trap all coarse particle, and then it is go pass through the fine screen. So fine screen will take care of other fines, all particulates, and it will goes to the your outlet, and that inbuilt having their suction nozzle. Okay, and water motor also inside for movement of this shaft. And during the operation also, this filter getting means going to the some after the delta P creating flush mode, so automatically they go to the flush mode. Next slide. So how it is work inside, it is, this is the one video, please start the video. So this is the filtration mode. So water comes from inlet, goes to the first core screen, that is outlet to in, out to in, sorry, in to out. Then water goes to the by using the shaft movement, it is goes to the next screen, that is fine screen. And when it is delta P gets above 5 psi, so automatically this inlet of inlet valve open. By using this vacuum, the shaft is rotating and do the cleaning inside this screen by using this shaft reverse flow, reversing acting. And all media, all screen get filtered by this flapper. 10 to 15 seconds required for one pass, and this it is indication it is cleaning mode is going on. That this all process from filtration to cleaning, it is automatically. Okay, no external mechanism required for this cleaning nozzles. So continuous, if you getting you are getting the outlet of water during also flushing mode also. So this is the one of the advantage, and only flush discharge is the only 1% of your feed water. So it is very least amount of wastewater is going during this flushing mode. Okay, next slide. Next slide, Suma.
Yeah, it's
So
in the next slide,
this is the
comparison.
this is the comparison of operation of all three, that is V series, electrical and piston. Electrical motor is required for electrical and piston only electrical motors, or it is not required in the V series and piston type, like limit switches, hydraulic pistons. So if you see, it is the total number of part required for this V series only 60 plus, but you see it is electrical and piston type, it is about 170 or about 270. So and this is a continuous flush capability in the V series only, because in single pass technology, it is not continuously it will take some time during this operation for the cleaning. 100% clean killed is happen only the electrical and V series. Next slide. So this is the advantages of that automatic self-cleaning filter. Screen barrier. So two types of screen is barrier is there. Work well with the organic and inorganic. Lowest flush waste, smallest footprint, less complicated. Differentiate with patented technology. So this is the advantages. Disadvantage like derate the organics and require some maintenance after some years, 1 years. This is the technology differential feature that is patented cleaning mechanism. Simplicity, minimal parts, no external shaft or seals required, no pistons or electrical motor required for this moving these shafts, and minimal maintenance. Next, installation and case studies. Please go down. This is our some installation. You can see. Please go down, where you can get the 50 microns of V200 series. This is power plant. You can get 50 micron, less than 50 micron. Next slide. This is for application on data center, where you can get 10 micron, less than 10 micron particle size outlet of the VAP filter. For irrigation or pre-treatment of UV seawater filtration directly. Next slide. This is for fish hatchery that before UV. Next slide. So this is one of the water injection for 25 micron packs. This is for food and beverages at 210 degree Fahrenheit. Next slide. Next slide.
Yeah,
So for
it's the
this
next slide.
is so this is for oil and gas applications. Next slide. If you see, it is 520 meter cube per hour, so you can get easily. So this is one of the 18 micron effluent equipment. This facility also 800 meter cube per hour for cooling water main plant supply. So we'll discuss also here that is sand filter. So what is the sand filter technology and what is about screen filtration technology. So sand filter, next slide. This is a sand filter installations. So this is a footprint and would require like that. This is the instrument or some walls. So this is surface and depth filtration, that is inlet to out, top to bottom, and backwash from back to bottom to top, reverse flow. Okay, and having some medias inside cores, fines, pebbles. Next slide. So this is the filtration arrangement, that is sand, the river water inlet from top to, and you get outlet water, filtrate water to bottom, and the same wall you can give the from backwash from bottom to wall, and you will backwash out from top. So it is basically top to bottom or bottom to top. So sand filtration has some advantages, that is work well with deformable particulate, that's organic, flocks and algae, higher loading characteristic, but they having major disadvantage that less effective, complex operation, uses clean water to backwash, means that clean water you can use for this backwash, higher flush waste, so that water gets going drain, and this is higher flow rate, higher maintenance and labor required, control wall hydraulics are complex, larger footprint. Okay, so as per this comparison that with the automatic screen filter with pressure sand filter, if you see that is cleaning operation, it is in screen filter automatically, backwash it is only 10 to 15 seconds, waste water per day it is very minimum, filtration quality constant footprint is very small, maintenance is very low and short time, and operating costs are still very low. But if you see for sand filter, it is very long, 10 to 20 minutes backwash required, higher flow rate, quality also some after sometimes it will go to inconsistent. Then also MOC, if you see, so corrosion resistant material having the automatic screen filter, that is SS316, and it is not steel, it is corrosive, weight is very low, and transportation also very low and not a very heavy. Okay, next
Yeah,
slide.
I think
So
the
this is
slide
from
ends here.
my side. So if you have any question, you can ask during last sessions. So if you have any questions, you can send me the mail. Okay, thanks for your patience and hearing this presentation. Thank you.
Thank you so much, Dattadre. I'm extremely sorry for the connectivity issues. There is some kind of issues going on in my side because of the low internet issues here. So now, thank you so much, Dattadre Patel, for your valuable presentation. Now, I would request our guest speaker, Mr. Shailesh Patel, to share his valuable information with the audience. Um,
Yeah, hi, Shimon.
yeah,
Yeah, good afternoon,
yeah, hi.
Evoca team. Good afternoon to Evoca team and all the attendees from the various places. Basically, I want to introduce myself. I am Shailesh Patel. I am heading this high purity water division in Permanix Membranes and Projects based in Baroda. It is in Gujarat, India. So for the Evoqua products, I can say one thing: there is a proven products with them actually, and I am using this product since long back from starting of my journey in high purity water division. So basically, we are using all these EDI models for pharma projects for the hot water sanitation purpose in that. That's the pharma applications for the US FDA. So starting from the 1 metric cube to the 5 metric cube that we are using in this. And secondly, we have a range of semiconductor in our projects for that we are using and giving the solutions for the solar cell application, where we are using the VNX Max modules. Basically, this 15 metric cube each module having that. We have a huge requirement up to 100 metric cube. So we are using almost 6 modules in the range of series. So ultimately, it is giving us advantage in the footprint. First point, which is very critical right now in this area. Second, we can see this is a capex. Also, we are reducing the capex in terms of this volume business is there. And second is the OPEX also there, where we are comparing with a mixed bed system and resin based system. Definitely, its OPEX is lower side with automation and system operation. And secondly, you can get all the continued results in the systems, because throughout the our conventional plant with the mixed bed resin, you can't get your regular results in that. There's lots of maintenance is requirement, manpower is requirement, but here in this case the automation is good. So definitely you are getting all the systems in the HMI and you are getting all the results with the SCADA operation in that. So that is we are using in that. And some products like UV for microbial and DOC removal, that is also a good range. Definitely in Indian market there are lower installations are there, but yes, now spreading of the solar cell application and the DOC requirement at the particular segment, definitely it's going in a huge way in the next coming years in that. And even with this filtration with this auto cycling filter is really good, where you can see lots of advantage in the footprint point of view, because somewhere we are using of the multi-gate filter with a higher range of footprint requirement, and here we are getting 30 micron side with a full automation system and without motor application in that. So you are operating your system with a lower kilowatt rating also. So this all package of these systems, EDI, UV, and your auto cycling filter, you can get a better advantage in CAPEX and OPEX in terms of your system design. So that basically, because we are using these products and we are satisfying with their service and products, so I'm recommending that you all must be use this in your products and systems as and when requirement. So I'm not using more time in that discussion because this is a huge subject for discussion. So that's all from my side. Hello.
Yeah, thank you so much, Shailesh Patel. It was a nice information from your end, and it was very informative for our audience as well, I'm sure. So
Yeah.
now the forum is open for the question and answers. Any questions from the attendees side, you can post the questions in the questions room. We will definitely answer them. There is one question which has come up, like for the CEDI technology, how much energy does CEDI consume as compared to MBDI technology? Uh, Pan, can you please answer this question?
Yeah, okay. So, in terms of the power consumption, That is the IP Pro software that we have at the Xylem website. It greatly depends on the feed water source. So the power consumption is not a lot. Hey, Suma, is it possible to share on my screen?
Yep.
Yes, okay.
Yeah, you can share your screen. Just a
Okay,
second.
all right. Are you going to
Yes,
share
you
my
can share
screen
your
for me?
screen. Yeah, you can share your
Okay.
screen.
Yeah. So what I've done, and that is like a Microsoft Excel sheet, so basically it's on the parameters. So that's based on an FCE, of like around 12 microsiemens, which is that's going to consist of like 5 microsiemens that is from the 2-pass RO, and then there's about 2.5 ppm CO2 and quite negligible silica. That is based on the quantity of the modules. Okay, and then it's also based on the flow rate, so it tells you in estimate, okay, what is the power consumption, that is kilowatt per day. That is assuming that you're running on a 24 hours 7-day basis. All right, so all these numbers are actually I try and derive it from the IP Pro software. So if you have your feed water parameters, if you have your if you have your flow rate and stuff like that, it can actually like tell you better in the software. But here is a slide of what I have. If you have like around 6 modules of VNX Max, it's close to like around 200 kilowatts per day. Yeah, so if you compare that into the conventional mixed bed system, if you run conventional mixed bed, they do not need any form of electricity, but it's more of the chemical it's more of the chemical consumption, all of the daily purchasing, and then there is the wastewater disposal too, which I've showed you in my slides. I think they cost a lot more in terms of the OPEX cost as compared to the CDI. I hope I have answered your question. Okay, back to you, Suma.
Thank you, Pan. Thank you. Next question is, what is the difference between the conventional filtration technology and the current technology you are talking about? This question is for the WAF, and this is to Dattadre Patel. Can you please
Yes, yes.
answer
Yeah,
this question?
so
Yeah.
the answer is that the conventional technology required is filter media, and this is that filter media that is fine, coarse, pebbles, and this is the system is like that. Conventional means that is inlet and outlet, and you giving the backwash like that, and filtration mode also in manual mode. So, and it will take a long time. After some you are getting the quality, it is not inconsistent quality after some time of operations. So, and this it will take filter water for backwashing. So if you compare with this our automatic screen filter, so it is fully automatic system. It doesn't having any filter media inside. This is only the screen, and the screen work for to accumulate all to remove the all particle, and the flush rate, that is same water can use for flushing or cleaning the screen, and the flush flow rate is very less, that is 1% of your total feed flow. And if you see, it is a long time we are using the conventional mixed see this filter. This is a they are again corrosive and all things, but in automatic screen filter having the SS316 material, so corrosion part also is very negligible. So this is the difference between, and also lower footprint of this WAP filter, and conventional filter required higher footprint. Okay, hope I think I am giving the answer.
Thank you, Dattadre Patil. And yeah, so any other questions, you can always post it to us, and you can also reach out to us. These are the mail IDs: the Pan Jia Singh, Samir Dasane, and Dattadre Patil, and sales.in@evoqua.com also is one of the platform you can reach out to us. Any other questions, you can put it in the chat box also. We will answer to that. We'll just wait for 5 minutes, and we can close the session. I think there are no more questions, so we can end this session.
Yes.
Yeah. Yeah, thank you so much. Thank you so much for all your attendance and participation. We look forward to your questions, and we look forward to any other doubts as well. Yeah, thank you so much. Thank you, the PAN, Samir and Dattadre, and thank you, Mr. Shailesh Patel, for being the guest speaker for today's webinar.
Thank you.
Thank you. Thank you. Bye
Thank
bye.
you. Yeah,
Thank you, everyone.
bye bye.
Thank you.
Thank you.